This video will explore objects and classes in Python. We've already taken a look at functions, we've looked at modules, we've looked at if-else statements, loops, and objects and classes will kind of give us the bit of a better option to encapsulate some functionality and behavior. So basically, classes or objects in Python, they allow you to associate some amount of data with the behaviors on how they actually operate. So classes specify objects. They are sort of like a blueprint or a specification for what an object can do and what information they can contain. We declare classes in Python with the class keyword, and they extend objects. So there's a whole concept of inheritance. If you've used other languages that are object oriented, you're probably familiar with it. But basically, objects can extend each other. They can inherit from other objects, and this allows them to take on their functionality. So in Python, we actually don't have constructors. We have an init function or an init method, and generally in Python this init is used to initialize the properties for a class, or allow us to kind of sort of construct an object, but it's a little bit different from what you might have as a constructor in another language. So we usually we use this notation of 2 underscores and then init followed by 2 more underscores. That's often called dunder, a dunder method in Python. That's kind of a common parlance. And then each one of these methods is going to have a self parameter, so kind of like this, but we have to explicitly use it to identify this as an objects method. So for example, if we have a pet class, this is maybe a little bit easier way to explain it. We have the class pet, and you can see that extends object. Then you have this init method. We define a method the same way we define a function with the def keyword, and the difference is that we always have this self parameter as the first parameter for any of our methods for our objects. So if we run this, basically what we do is we now have a pet object that is defined with a name and an age parameter. So using this and instantiating your object, you don't actually use the new keyword like you might in Java or C#. We run this and you can see my dog is equal to pet Fido. So pet creates this class which implicitly calls that init method. Note that self isn't used here, but we do pass in the name and the age of that pet. And you can see that this is populating these properties just as you might expect. So here you can see my cat is equal to a pet, and then we pass in the name and the age. So my cat.age is going to give us 7. So Python objects are dynamic, meaning that you can populate them anywhere. So we can actually throw in the colors for this dog, and we can add that as a property to that particular object. So we instantiated this object here, and here we can just define a new property kind of on the fly. Methods in Python, we declare them like functions. We use def. So if we want to define a particular method for the object, we still use self, we still use def, but since this is something we're going to call on the object itself, we're going to redefine this object, and then here you can see, I do actually have a dog named Lily. So when we create the pet object, Lily is 6. Lily is actually, I think, 7 now, but we will call, so my dog.call, and then you can see here that's going to output here, and then the dog or the pet's name. Methods can also return a value just like other languages. So here we have, we're defining the pet object further. We have init, and then we have call, and then we can actually return the call. So you can see here now instead of just printing it out, we're actually going to retrieve it using get call, and here you can see this is this allows us to define a method with a return value. Now, there are other methods beyond just this init method, these other special dunder methods. Probably the most common one is str, which is used when we call string, to convert to a string. So when we now use this, we have this str method that we've defined, and because we have that, we can print that object directly. So you can see here, this print is actually going to call str to convert the object to a string, and it's going to return this particular value. So you can see it's going to concatenate the name with is and then the age of that pet. A few other methods that we might want to use, length, len, contains for the in keyword, and add. These allow us to use, like I said, length, in, and the plus operator. So if we define these methods, now we can do all sorts of strange things like we can, if we have a points object, we can All right, let's go ahead and run that to define the class. Now we can define a list of points. Maybe we use this to sort of define lines. We can use len, because that just calls the underscore underscore len underscore underscore method. We can identify the contains method. So you can see here we are just calling into this one. And we can use add. So, you know, if we add these together, you can see what this is going to do is just concatenate these two lists of points. So 7, 9, and 4, 11. So we're just adding all of them together. So this allows you to kind of use different operators and different functions with your objects by default. There's several others, you know, like we can use comparison operators like less than, equal to, greater than, equal to, equals or not equals to. So, you know, there are a lot of other built-in methods. If you want to take a look at the documentation, it's all out there. Now, one thing that you might see, if you forget to use the self keyword, you'll end up with class properties similar to what you might have with a static in Java. You know, so if we have a counter, you know, so this one here, for example, count equals 0, that's going to be now a class property, and if we initialize this, it's going to add 1 to counter. So you can see you have to use the class name to actually access that. And then when we retrieve it, we're going to just return that value. So if we define 3 new counter objects and then retrieve that count, you'll see that this count kind of belongs to the counter class itself. Each one of these is not going to have 0. It's just going to add 1 to each one. So you can see how we can define those class level properties that way. You can also remove object properties. So, you know, we can use del to the delete, you know, sort of keyword del. And if we define this class and then we delete this one, if we try to run this now, we'll see, oh, that actually doesn't work. You know, you can't do that. So let's go ahead and we'll run this again. There we go. Now that's just fine. In fact, you can delete the entire object. So that just removes that, and then if you try to access that one, you'll get an error on that one as well. So again, with inheritance, we can actually create a sort of an object hierarchy that allows us to create subclasses and inherit behaviors from our other classes. So the pet object, we could define this, and then we could have a dog and a cat, and that way, you know, this allows us to have different behaviors for each one of these subclasses. So this is going to define a pet class, and then just a dog class that just demonstrates that, you know, we're extending from pet. It doesn't actually do anything special. However, down in this next code block, we can actually define a slightly different behavior. So now we can see, you know, with a pet, we define a name and an age, but here we actually don't define the name and an age. So, you know, we don't implicitly inherit that behavior, that you know, what happens in that super class or initializer. So to call the parent class as init method, you have to use the kind of awkward syntax. So this is a little bit, you know, so basically we call super and then this weird method here. So that's kind of awkward, you know, but it allows us to inherit that and use that same superclass functionality. In practice, you probably won't see a whole lot of class hierarchy, you know, a lot of inheritance in Python, but, you know, just in case you do need to call the superclass constructor or initializer method, that's how you're going to go ahead and do it. So if we run this, we should see, there we go. So this does set the name properly. So unlike this one, which will only set the dog's breed, it doesn't actually set the name. So here you can see we've defined a dog, Perry the poodle, age 3, and if we access the name, basically when we call the dog or create the dog object, it's going to call into the init method. It's going to use these parameters, name, age, and breed, and then we're going to call the superclass initializer with name and age. So you know, kind of all operates. A little awkward, but it works. All right, next we're going to get into Python errors and files. We'll show how we can kind of raise exceptions in Python. But for now, thanks for watching this one, and we'll catch up with you again soon.